Welcome to my second video on the Pegasus R6 Thunderbolt RAID from Promise Technology Inc. The first video looked at setting up and configuring the RAID using the Promise utility which is supplied with it. This video looks at benchmarking the RAID and seeing what performance it can achieve. Just to describe the test environment, I was using a Pegasus R6 RAID with 6 drives of 1 TB each. I use a 27-inch iMac with a 3.4 GHz Intel Core i7 running OS X version 10.8. I originally intended to use the Blackmagic disk speed software, which is available from the App Store for free, but its results were far too inconsistent and I devised my own method to test. You should note I'm interested in measuring sustained throughput in terms of megabytes a second, not random I/O or seek time. My test method involved using the terminal, which is available in applications/utilities, and using the Unix dd command to read blocks of data from memory and write these in 1 MB chunks to the Promise RAID. I read from memory because it can sustain many gigabytes per second and therefore won't slow down the disk. To avoid the effects of caching, I wrote and read files of over 100 gigabytes in size, as the iMac can certainly not hold that volume of data in its RAM. The dd command usefully tells you the data rate achieved at the end. Briefly, the commands I used were the upper one here, which reads data from memory. You see if input file equals /dev/0, and then writes to a file on the Promise RAID called junk, and the block size is set to 1024K, which is a megabyte, and the count, or the number of blocks, is 100,000, which makes basically a 100 gigabyte file. I then used the purge command to clear the OS X caches. Then I used the second command you can see on the screen to read the 100 gigabyte file back from the Pegasus, again in 1 megabyte chunks, and to discard the file to the trash can, which is called /dev/null. That's the output file is /dev/null. You can get help or look at the manual pages using the man command in terminal, followed by the name of the command you're interested in. So to get help on the dd command, type man space dd and then hit enter. Press the spacebar to read further and Q to quit. I also ran the built-in activity monitor, which you can find in applications/utilities whilst I did the tests, and selected disk activity to see the read-write rates that the Pegasus RAID achieved. I noted that these actually corresponded extremely well to the speeds I measured with the dd command, so I have pretty good confidence in the results. Okay, here are the results. I've put them all together in a table. Down the left-hand side here, you can see the number of drives that I configured into the RAID array, and across the top here you can see the different RAID versions or types or numbers that I was using. Note that all the cells aren't full because I didn't test every single combination. Mainly because some of them aren't possible, secondly because some of them aren't really interesting to me, and thirdly because it takes up to 24 hours to reconfigure the RAID for each test. So with a 5x5 table I would be here for 25 days testing, so I didn't do that. Okay, let's look at the results and how to interpret them. If we look up here at a 2-drive RAID 0, if we have 2 1 TB drives in a RAID 0, that will give us 2 TB of space, and according to my calculations that's 100% efficient space utilization. If we have 3 1 TB drives in a RAID 0, you'll get 3 TB of usable space, also 100% efficient. If we look at a RAID 5 with 5 drives, you can see one of the 5 drives will be used for parity, so you'll get 4 TB of usable space, but as you'll be using 5 TB of disk to achieve it, I make that an 80% space efficiency. So that's what That's what that entry in each cell means, the first one. It's the usable capacity and the space efficiency. The next number in each cell is the sustained write speed in millions of bytes per second. A megabyte is 1.05 million bytes, so basically this number here differs from megabytes per second by about 5%. So basically a 2-drive RAID 0 is going to achieve 368 million bytes per second of sustained write speed. Similarly, the sustained read speed is 365 million bytes per second. Okay, so let's have a look and see what we can work out and deduce from these numbers. Firstly, if we look at a 2-drive RAID 0, we're getting 368 and 365 millions of bytes per second. So basically we can say we're getting about 180 million bytes per second from each disk. That's fair enough. If we look down at 3-drive RAID 0, we can also say that if we say 3 lots of 180 are roughly 526, although it's actually 540, we can see that it's true to say that each drive is giving us about 180 million bytes per second. So if we look across at a RAID 5 with 3 drives, we can see here that we're getting 351 and 358. So what we can say is that adding an extra drive with parity doesn't cause the other disks to be able to read or write data any faster or any slower. So actually a more accurate statement would be that each usable drive is giving you around 180 megabytes a second. So that's pretty good. If we carry on a little further down the table, so let's say we look at a 2-drive RAID 0, that's getting us 365 million bytes a second of read, and a 3-drive RAID 0 is getting us 480 million bytes a second. You can see when we get to a 4-drive RAID 0 that the read has only reached to 507 million bytes a second, and even if we go up to a 6-drive RAID 0, the read speed still only gets to 504 million bytes per second. So I think it's pretty fair to say that we saturate the read controller around 500 megabytes a second. We're just not going to get any more out of it than that when we try and read. If we look at the write speeds, we can see that in fact we can get higher numbers. It can go up to 624 megabytes a second for 4 drives in a RAID 0 and 626 million bytes per second for 6 drives in a RAID 0. So effectively that's the top speed we're going to get out of the disk, 626 million bytes per second. So being a fairly curious sort of a person, I wondered if I could maybe improve on these best performance figures we can see here by maybe making 2 different RAID drives and pairing them together under OS X using the disk utility's inbuilt software RAID striping. So here are the results of that slightly mad test. I'm basically making 2 RAID 0 arrays with 3 drives in each on the Pegasus, and that appears to OS X as 2 separate drives, and then I do an OS X software stripe across the 2 drives, and basically that gives me a write speed of 636 million bytes per second and a read speed of 563 million bytes per second, so that is marginally more performance. The second test I did was to make a 4-drive RAID 0 on the Pegasus and a 2-drive RAID 0 on the Pegasus, and stripe those 2 together using OS X software stripe in disk utility, albeit wasting quite a lot of space there. And that gave me a write performance of 638 million bytes per second and a read performance of 542 million bytes per second. So you can get marginally more performance with doing something crazy like this, but you'd have to be extremely desperate for those last few percent of performance to do something like that, rather than take the obvious 5 or 6 drive RAID 5 or RAID 6. In summary, the Pegasus Thunderbolt RAID is blazingly fast, and it's actually the match of many SSDs, solid-state disks, at least in terms of sustained sequential throughput, though probably not in terms of random I/O. As regards the best configuration, well, that depends on your intended use, whether you're going to use it for databases, video, photo editing, or whatever. But it's fairly easy to see why Promise Technology ships the R6 configured as a 6-drive RAID 5, because that is almost as fast as any other RAID level, offers a high space efficiency and a good amount of resilience to disk failure. One other thing, I noted, as with nearly all disks, the performance is better significantly at the outer edge of the disk than towards the centre of the disk nearer the spindle. This is because the inner and outer parts of the disk are turning the same number of revs per second, but at the outer edge a much greater area of disk surface passes underneath the head in the same time because the radius is greater there. In order to test that, I made a 5 terabyte array on the Promise and made the first partition 100 gigabytes in disk utility, followed by another partition of 4,800 gigabytes and a final 100 gigabyte partition, which was then at the center of the disk. The drive actually sustained 550 megabytes a second in the first 100 gigabyte partition, but barely managed 300 megabytes per second in the final partition. So if you're using this drive and you want to place things in the very fastest area, place that data at the outer edge of the disk or the first partition in disk utility.